From Shield Studio 22A, this is the Safety Synergy Podcast. I'm Elliot Laratonda. My guest today is Dr. Nathan Smith. Dr. Nathan Smith is an assistant teaching professor in the Department of Material Science Engineering here at Penn State. He acquired a bachelor's degree in physics, mathematics, and ancient history from the University of Maryland, Baltimore County in 2014, and his PhD in material science engineering in 2018. Dr. Smith now leads the Laboratory Safety Managers Group in MATSE and assists in maintaining safety in Steitel building. So thanks for coming.
Yeah, thanks for having me, Elliot. It's a pleasure to come by.
It's a nice place, right?
Plus, I owe you. You've been a really good EHS rep, and so you need me for something.
Well, that's exactly how we like to start off the podcast.
Yep. Yeah,
Compliments
you
for
got
me.
a lot of favors to call in on people, so, here I am.
Yeah, well, appreciate that. So it's an awesome perspective that you bring in this first conversation coming from research, right? I mean, as a researcher at Penn State in material science engineering, right? So can you talk about your experience or what you studied in your research? And
Sure. So I came here in 2014 to start my PhD. I worked with Dr. Ho-Jung Kim. So my area of expertise is what's called high-temperature electrochemistry. So from a safety perspective, we're dealing with a lot of things that are vulnerable to moisture and air. Worked with a lot of metals like lithium or cesium, strontium, your alkaline earths, which are volatile, with respect to air anyway. They can certainly oxidize or they can even catch fire if the surface area is high enough.
Sure.
Otherwise, a lot of high temperatures. So we ran a lot of our measurements, between roughly 450 and maybe 1,000 Celsius. And so we have a lot of furnaces in the lab. Because of those air and moisture sensitive materials, we have a lot of glove boxes, which necessitate gas cylinders. And we had to make a lot of our own equipment, electrodes, things like that, because it's kind of a niche area. You can't buy a lot of stuff. So that involved machining. So I was working with lathes, just a lot of, cutting tools, things like that. So, from a safety perspective, there's some things to be concerned about there. And we made a lot of our own alloys, things like that too. So I was working with fairly high potentials currents with arc melters, induction melters, things like that.
So the Dr. Kim lab hasn't changed too much, it sounds like, right? Because that's a group that, I would work with. And so metals in a glove box, furnaces contained to that glove box, you're making your alloy and testing it. Did you work at the time, was MSC around in MRI or was it more?
So when I arrived, MRI and MSC were pretty functional as they are today. I used a lot of the user facilities over there for things like X-ray and SEM. When I arrived, Steitel was actually just starting its renovation. So I signed my paperwork in summer 2014 in old Steitel, and then by the time I came back in August, it was closed off. And so I was out in temp space by the stadium called Research Unit A.
Okay.
That was where I did research for 2 years or so while Steitel was being renovated, and we move into the brand new building.
So you went from your PhD right into Steitel. You didn't go elsewhere and work.
This was all during my PhD. So I started my
gotcha.
PhD working in that temp space, and I finished it in Steitel.
And then transitioned into your full-time role.
So actually, I had some intermediate stuff. So after I defended my PhD, I got that 2018 fall, and so I stayed on in Dr. Kim's group because I hadn't really been looking for jobs yet. So I stayed on until, I guess, through spring, and I got a job at Argonne National Lab out in the Chicago area. So I moved out there probably around July, August, probably around there in 2019. And so there I was working at some new hazards, I suppose, because I was still working on high-temperature electrochemistry, but there I was actually able to use radioactive elements instead of just the analogs that we use in Dr. Kim's group. We're not allowed to work with stuff that's radioactive, so we use elements like cerium, neodymium, gadolinium, a lot of the rare earths that are not radioactive but serve as decent analogs for things like uranium or plutonium. But I go to Argonne, I actually work, I'm turning uranium oxide back into uranium metal for reuse in nuclear reactors, spent fuel recovery, things like that. So I worked out there for a year, got, used to a lot of the protocols and had to go through a lot more significant rad training. So we had, a health physics tech there. Anytime you go in or out of the lab, you got to use the hand and foot sensors for any radiation, particles you might have picked up or anything. And those things, if you set them off, you got to wait for health physics to come let you out because you get screened. And that happens fairly often because they're sensitive enough. You walk through morning dew, something like that, and it picks up enough radon that you're going to trip the sensor. So one guy had like a CAT scan or a PET scan or something, and he couldn't go in the lab for a month. He'd set off the sensors through the wall practically. So I got some more experience with rad stuff there than I'd previously had. I mean, I'd used X-ray and whatnot, so I have some training. But I actually was working with, uranium oxide and uranium powders and whatnot, which was a lot of fun.
Well, let's talk about your full-time gig, if you don't mind. What classes do you teach? Tell us about your experience, or maybe it changes from each semester.
I'm trying to sort of move towards a set that I just repeat because it gets easier the more times you run a class, the less work it takes, as I'm sure you're learning with yours, right? The first time is a huge amount of effort. The second time is maybe like a quarter of that, and then any subsequent time is basically just you teach the lectures and you change a few questions here and there.
Exactly.
But I teach our introductory class, MATC 201, which is the Introduction to Material Science and Engineering. I teach that every fall and summer. I teach right now ceramics processing, a lecture course for seniors, and I teach the associated laboratory, so ceramics processing lab. I teach a senior level thermal properties class, and I teach technical writing. I have a new history of materials, sort of cross-disciplinary class coming up this spring. But yeah, that's most of my work is teaching those courses.
What percentage of those did you feel like when you were assigned the course, like, that's right up my alley, no problem, versus like...
Really none of them. Math is not exactly my background. My undergraduate degrees are physics and mathematics.
Yeah, I was amazed to see that. I didn't know that. I mean,
and I guess ancient studies, which is a sort of...
So those are each majors that you had? Is that so triple major?
Yeah.
Oh, okay.
I was a busy guy.
Yeah, sounds like it.
But a lot of fun. But, I mean, for my PhD in MATC, I only had to take 6 classes, and 3 of those were electives, so they were my choice. So those kind of I funneled more towards the electrochem background. So honestly, my classical training in MATC from a course perspective is very limited.
Gotcha. Now it's all making sense.
A lot of the stuff I just had to kind of learn as I was given the class to an extent. I mean, some of them are based a little bit on my background. I'm not a polymers guy, so they don't give me anything organic, which I appreciate because I have never had a class that's even really so much as touched on polymers.
Yeah,
so
keep it with solids.
They're really not my thing. But my physics background lended me somewhat well to teaching thermal properties because there's a lot of physics behind heat capacity, thermal conductivity, things like that. So I picked that up reasonably well, and I think that's probably my favorite class to teach. The intro class is a low enough level that it really wasn't a significant problem. I mean, there's some stuff I had to brush up on that I wasn't used to, but because it's taught at a sophomore level, it's not really a big deal. The other stuff, ceramics processing, I shadowed the previous faculty member back when she was sort of retiring and I was phasing in. So I got some good experience from her, but that one is still something I'm definitely picking up because this is my first semester teaching it, and it's not really my field of expertise. It's increasingly becoming as I learn more about it because you got to learn to teach.
It's exciting, yeah.
And so I honestly probably have learned most of the stuff even back in undergrad when I was like helping other students or being a TA or being a tutor or things like that. I always learn way more by teaching than I do just sitting in a course. So I'm starting to get better at a lot of these subjects, but I still got a long way to go to really reach expertise.
Yeah, and I'm new to it here at Penn State, so I was hoping we could kind of trade some notes. What do you think are the challenges of teaching now and today, this day and age that we live in, right?
Sure. I mean, AI is probably the biggest one everybody talks about. I mean, I ran a little test in 201 last fall just to kind of see how many of my students, because I had an online section, I did all the exams for all the sections, my 2 in-person and online. They were all online, and if something's online, I'm like, okay, it's open book, it's open note. I just tell them, you can't use other people or AI. And so I put in a little white text into one of the questions just so that if you copied and pasted it into something, I would be able to tell because I just changed one of the values via the white text. There's just a little bit of hidden text that says, hey, change the, resistance by a factor of 50 or something. So I caught about 5th of the students. So it was about 40 students that fell for that one. Wow. And that's just ones that had copy pasted it. I mean, plenty more might have just actually screenshotted or, there's other, or noticed what I did if they happened to, read what was being highlighted when they were doing it. So after that, I just decided there's no more in-person or no more online exams.
Exactly.
So,
it's becoming practically impossible nowadays.
Yep.
We talked about this.
I just had my first exam this semester that was in person or using the Pollock Testing Center for the online section.
So it's just proctored or whatever.
Yeah, it's a little bit more secure.
Okay, good to know.
In that way, and the average was a good 15-20% lower than it was last.
And which of these are online versus in person?
201 is the only one of mine that has an online component. I teach 2 lectures of it in person every Monday, Wednesday, Friday, but sometimes we have some branch campus students. We have chemical engineers and biomedical that sometimes take it for interest or for credit towards their degrees, and so they're not required required to do the in-person, but we do require all MATC majors that are on campus have to take the in-person.
You prefer in-person?
Yeah, I do.
Oh, yeah.
I like the actual act of teaching,
Exactly.
as I can kind of gauge what people are understanding, what I need to spend more time on, what they don't. You can see it in their faces usually. For a lot of times, it's tough to understand the first time. I always tell people you usually need to see material like 3 separate times before you really start to get it off. Yeah. But it just helps, with the flow. Online, I feel like more of a manager than an actual teacher.
Yeah, it's just like, purely administrative,
here's
clerical.
I record all my lectures for 201, so we have a nice recording studio that Kay DeMarco from E. Dutton runs, which is great. And so that's been helpful because they can watch the videos of my lectures. But as far as what I feel, I feel just like a moderator, like, hey, I'm here if you have questions. And, most of the time people don't ask me too much from
takes
the
teaching
section.
out of it.
So, yeah. It takes out the aspect that I really actually enjoy, which is, working directly with the students.
Yeah, and finding gaps and helping people where they need it. I think the aspect I enjoy the most is like I've always found pride in like conveying something in a way that people actually understand. I think so many people and probably teachers that we've all had at some point, they just kind of talk, but like there's something different between like saying something so people truly absorb it, digest it, and understand what you mean versus just talking.
Yeah, it feels good when you get that sort of see that something's clicked and things like that.
Exactly.
So, I'm happy to do the online sections because they're important to be offered, but it's not my preference. I prefer to just have a lecture in person. I go and I teach.
What's your perspective on like the different ages? Because I've seen and taught to freshmen, like a 101 level, and now here in MATC, my course is senior level, and I see a big difference in
certainly, yeah. I don't really teach freshmen very often. 201's a sophomore course, so maybe I'll get some when I teach the history materials in the spring, which will be fun. It is obviously wide variety of student quality in any given year. You have some freshmen or sophomores that are, you can tell already that they're truly elite students and they're going to be, they just crush it and they're really involved. But overall, I think when they become seniors is honestly kind of the first time I start to see them as like an actual adult instead of like a child. Because I don't know, there's just something that flips between junior and senior year over that summer where they seem to have a lot more confidence. They kind of almost change, and you can see, okay, like I can see this person in grad school, I can see them in the workforce. Whereas like the previous 3 years are just kind of like, it's like they might be a good student, they might be a bad student, but they still just seem like kids.
In my experience with the 111, the freshman level, I would say that maybe 30% probably aren't going to stay in college, so it was tough to kind of
you get less of that with each level. I mean, I got plenty of students that are just average at best at the senior level, but at that point you can tell pretty much everyone's going to make it through, and really they're still typically quite smart. It's just some of them need to be a little more diligent and handling things in, being on time and things like that. But you do end up with some students, I think, that work their way either out of the major or out of college if it becomes clear early on that it's not going to be the right fit for them, which is fine. You got to find what's right for you.
Right.
But this is just something that changes, especially between junior and senior year, I would say, where you start to see them as like young professionals instead of students. It's like, okay, like I could see this person in an engineering role at a company or as a grad student.
Yeah.
It's like, they got that feel to them. So
for sure,
that's where I see the biggest change, I would say.
To pivot to, not to call it the side gig, but right. So in addition to your full-time teaching responsibilities, you manage the LSMs. Can you talk about what is an LSM? What does the acronym mean? What do they do, and your role in managing this LSM group?
Yeah, so the LSM group stands for the Lab Safety Managers. So this is particular at Steidel Building, but I mean, Sarah would have talked to me of the same program at MSC.
Sure.
So, these are used for both. It was a group that kind of actually, I remember it first developed when I was in grad school. I was one of the first LSMs back then, so I kind of was a natural fit to take it over eventually. Libby Cupp ran it, and my old friend Cassie was one of the heads, and I was like one of the chairs for a year or two after that. So the group kind of started out of just a desire to improve safety in MATC. Now we're kind of held up, I think, as a fairly high standard in safety as far as the university goes, but it wasn't always that way. Even when I had first started, things were only, they're slowly starting to improve. But Dr. Messing, Gary Messing, one of our previous department heads while I was in grad school, had a big focus on safety and trying to push us up to industry standard levels and like good industry standard. And so that group kind of started just to have a representative from each research group who's a grad student that attends meetings every couple weeks or so to discuss safety topics and help improve safety and just keep a general sort of good way. It really is just to ideally have somebody that acts as a good bridge between safety and the advisor, because you're never going to get the faculty in these sorts of meetings that often or anything like that. But you can definitely get grad students. And so then, they act as a way to inform faculty and, kind of just get better dialogue between everybody.
That's how I would describe it. The conduit to the responsible person. Because as we know, the PI truly is responsible for the research operations, the hazard that students are exposed to, but they're busy folks. And so we have to have that person that kind of facilitates those responsibilities kind of on their behalf. So I like to describe it in that way.
Yep.
How would we describe their kind of day-to-day or more like concrete responsibilities? Like, for example, just on the surface, an easy one to point to is they might maintain safety documentation. Sure. So whether that's a routine self-inspection, SOPs being a big one, maybe a chemical inventory, anything else come to mind? Or if not, we could talk to maybe what an agenda of like a committee meeting kind of looks like, or maybe MATC specific duties outside of EHS.
Yeah. I'm going to talk about that. Actually, Jessica Sly, one of my previous chairs, actually wrote an SOP for being an LSM, which I just kind of co-opted and, made minor alterations to generalize it.
It's a great idea.
Based on some of the stuff. Their primary responsibilities, aside from just acting as that conduit, it's generally expected that they help to facilitate safety moments, a little, brief intro at the start of any group meeting to discuss safety within their own groups. They are supposed to help, again, their role isn't to do all of this, but to ensure that it is done.
Exactly.
So I always tell them, you don't have to do all these things. You can delegate some of this to members in your group, but you're responsible for making sure it's handled. So they are responsible for, ensuring that the safety documentation is handled. Mostly that's going to be the SAA, satellite accumulation area, and IWASH checks every week. Mm-hmm. So those are important. They are responsible for ensuring the chemical inventory is completed. Some people, ideally it'd be updated as chemicals come in and leave. Most people do it the one time a year that it's required.
Yeah, or somewhere in between. Yeah.
Or at increments in between. Mm-hmm. They are also responsible, for maintaining sort of that documentation that's moving to Lion Safe, things like the unit-specific plan, which is, now being sort of translated into the Lion Safe risk assessment, which is, I think an improvement. And I think those are probably their primary responsibilities, as well as just keep a general eye on the laboratory and bring up any safety concerns or things like that to me or to Dustin or Cody or other folks who are responsible for safety in the building. And so, we have meetings probably every 3 weeks or so is probably about right. So 1 to 2 meetings a month. And so those typically...
It's kind of frequent, in my opinion.
Yeah, there's just different stuff. Sometimes we'll have a guest speaker, like you've been a guest speaker for a number of the meetings before, which is great. Mm-hmm. Sometimes it will be, like recently, the most recent meeting I had was just to work on updating signage and Stidle, because we had a new set of LSMs come in at the beginning of the fall. We have people sort of switch off. We try to aim for roughly a year, long, so that we don't have people switching out throughout the year.
Right.
Just, one big turnover. And so one of the things I had the last meeting is like, okay, let's get all the door signs updated, because our door signage has contact info for all the LSMs, as well as the spaces, as well as we have individual bench signs that indicates, the hazards and who's responsible and their contact info. And so a lot of those get out of date as LSMs graduate or leave or things like that. So I just had a meeting where it's like, okay, here's new forms. Let's go fill them out. And I'm going to check this Friday and make sure all of them have been updated. And then I'll go bother anybody that hasn't done it. So that's an example of one of them. We have a meeting specifically about the chemical inventory or specifically about preparing for the EHS audits and things like that. Just to we had, here's a list of things that are going to be checked for. Your lab should be doing these anyway, but let's go through and make sure everything's in good shape. So it really depends on what issues we're having is what directs the focus of the meetings. Yeah,
I would say whether, in your group, we call them lab safety managers, others around the campus might call them lab safety officers, whatever the title is. It's a spectrum between you representing the top end, and you and Sarah, and the amount of initiatives independent to your units versus groups that don't do much of any of that. And it's kind of anywhere in between. So I always point to you guys, both MRI and MATC, as being the champions for how that model should look.
I think it's worked reasonably well. Not that we're without safety incidents, but the push is always driving them towards zero and understanding, what issues are common and what we can easily fix. And, there's always some things, we've been dealing with, some flooding issues and things like that we're not, it's outside of our department's control that we have to try and force more change at a higher level. So.
And so let's articulate the lab structure, for people to visualize kind of MATC and Stidle and how it looks. We mentioned this in a previous session about the open concept. So let's two-prong question. One, can we characterize the research or like kind of catalog by different like specialty or group? So like polymers versus et cetera. I'll let you explain. And then let's also talk about like the physical lab setting and what they look like.
Sure. So, I mean, cataloging by area would just take too much time. I mean, we have faculty in all, in Stidle, we have people working in, ceramics, polymers, metals, all sorts of different areas, and those break down to a wide variety of, sub areas of interest and research. We do have less of the semiconductor people in Stidle because they are mostly over at MSC because the clean room's over there.
Right.
So that's one area where we don't really have as much work at Stidle. You have faculty doing anything and everything from a research standpoint.
So it'd be appropriate to categorize by material type: polymer, metal, ceramic.
Possibly. I mean, that doesn't necessarily give you a good
Cover
idea
it,
of the safety or things like that. So it really does have to be done at an individual group level.
Yeah, sure. Okay.
Which they have the documentation and assessments to handle.
Mm-hmm.
And you could generally stamp that, but that doesn't, just because someone works with polymers doesn't mean there's necessarily an innate hazard compared to somebody else or anything like that.
Right.
It really depends on what they're doing. Dr. Colby, for instance, works with cellulose. Is not going to be particularly dangerous in a lot of ways, where somebody, might be working with a particularly harmful polymer or with a particularly dangerous process or something like that. So, but the lab design is fairly open concept in Stidle. So we have a lot of glass windows. You can see directly into all of the lab spaces, and the lab spaces are shared in the sense that they're big, large open rooms, but they're not shared in the sense that it's not like different groups are using the same direct bench space. Everybody sort of has their territory carved out in the large open areas. So we have maps that we've developed that show which benches belong to which people, and those can change as people retire or are hired or things like that. But the open concept is helpful because honestly, the labs that you're always going to have the biggest issues with are ones that are not frequently seen, because we have all these people walking into the building. The second you walk in the building, you're immediately looking into lab space, and this is going to be the case on all the floors. You walk across, you can see all throughout the lab and into it, which means, one, as safety people, we can see much easier. Now, if someone's not wearing safety glasses, I can go see them, and I go in and I can give them a warning or escalate it from there if it's more than one time that this has happened.
Yeah.
But it also means, because we obviously have we have people come by that are very important, in terms of alumni or industry visitors or other people that might be interested in donating a significant amount of money to the department or things like that. There's always been a very strong departmental push that the labs look good, and looking good is honestly, it's not equivalent to being safe, but there's some overlap, because it means there's going to be a lack of clutter and things like that. And the labs that we often have had the biggest issues with are ones that are more secluded.
Gotcha.
Where you can't really see that much into them or things like that.
That's what I was going to point to, is like the primary benefit is just like there's no out of sight, like everyone's in plain sight, and whether it's industry advisory or the PIs or people filling some safety role, they're going to walk through your space, and you can't. There's no room to hide, and so that's helpful.
Our safety folks do. I mean, like Dustin and Cody, and, they do walkthroughs at least once a week, often multiple times. They'll go through the building, and it's easy to quickly move through the labs and try to catch anything that might be incorrect.
I could say there could be challenges though, right? Because sometimes it's hard to tell whose stuff is which, right? Because you can lose that
for us, we do have those bench labels and stuff like that, so we generally know. And of course, for the people within the groups, they're very aware of what's whose and what space belongs to who. So, it is typically divided on a bench by bench kind of basis.
Gotcha.
So, but for any random person walking through, it wouldn't be immediately clear. But, for the people in the groups, it is. And then we do have the labels on all the benches. So for those of us walking through, we can be like, okay, this is so.
That definitely helps. And that's something that in other open concepts I haven't seen, right? And then becomes even harder if something gets misplaced or whatever. Then it's hard to tell who's responsible for what. But that does help, no doubt. So safety responsibilities and cleverly are distributed in MATC. You mentioned Dustin and Cody and how they help. Can you talk about that, how safety is kind of distributed with different personnel and staff to support it?
Yeah, sure. So, I mean, there's a lot of overlap. I wouldn't say we necessarily have incredibly clear delineations because we do work together on a lot of stuff. I would say myself and Dustin, primarily Dustin, are the two biggest sort of safety presences in Stidle Building. My primary responsibility, I would say, is running the LSM group. That's really kind of what's clearly defined in my role, whereas Dustin does things a lot more from sort of the more maintenance kind of staff side of things.
General
so Dustin,
support, liaison to EHS.
Yeah, he does more of the liaison to EHS. I'm more of a liaison with the faculty and students. So, I present safety moments at the beginning of every faculty meeting, and I organize the students that do the stall walls for the bathrooms or that do the safety moments at the beginning of the grad seminars or things like that. So I'm a little bit more student-facing, whereas I'd say Dustin's probably a little more facility-facing. But, things like he does, he manages all of the swipe access and things like that to the lab spaces, and he checks all of the safety training for all the students that are authorized to use the labs to see if they've expired or if they have the right trainings and things like that, as well as he's often dealing with some of the more physical issues, if stuff needs to be removed, if there's bulk waste coordination or something breaks or is damaged and needs something like that. He's usually a little bit more present, I would say, for that sort of stuff. So that's kind of how our roles are split. And then Cody, of course, in his role is more of sort of the user facilities oversight. So he's involved in a lot of those bigger aspects.
And something to key in on is the card swipe access in connection to EHS training or even equipment-specific training that's tied to maybe computer access and control of certain instruments. Could you talk about that?
Yeah, so it is tied specifically to the lab access. So we do require, a user facility form that basically for each individual piece of equipment that basically says if I break this, my advisor is going to pay, the amount of money to fix it.
Sure.
But the way we gate our lab spaces, and this goes for the big open ones as well as all the individual first floor labs, is essentially in order to get card access, you have to fill out a form. It's signed by your advisor, and if it involves the first floor labs, it's signed by me. But basically, it's signed by some faculty member that says, yeah, I'm okay with my student or ex-student using these lab spaces. And when we go to process that, Dustin, when he goes to add that swipe access for those people, checks their EHS and MATC safety trainings. And if those are not on file, the access is not granted. So we can, and then if their form expires, they haven't done the refresher within a year as is required, then we simply remove the card access. So Dustin keeps all of those, they're always up to date for everybody. Yeah. So if somebody doesn't handle it, then we simply cut their card access, and usually then they're going to come crawling back to do what they need to do.
Exactly. Yeah.
But generally that doesn't happen super often.
Yeah.
But that's how things are handled. So if you have access to the lab space, we know that you have taken the requisite trainings and refreshers.
Is there some same idea of getting like an instrument-specific training, the safety, or just the general operation so you don't break it, that's tied to their control and access to the computer software that...
So that is tied, that's a little bit different safety-wise. It's not tied to the trainings in the sense that what happens basically, say you want to use a piece of equipment on the first floor lab. So this doesn't apply to any of the equipment for, specific research groups because they just ensure that their people are trained.
Yes.
But if you want to use one of the user facility pieces of equipment that I manage in the first floor labs, of which we probably have roughly 30 to 40 pieces of equipment, what you do is after you complete the swipe access and the user facility form, then in order for me to give you an account on the software that allows you to use those instruments, you have to meet with me and I go through, a brief training session on the piece of equipment. It may vary depending on your experience or who you're working with or the complexity of the instrument or your measurements. And so that's how I sort of guarantee that people shouldn't be breaking the instruments because I go over, safety procedures and things during that. So they can't use the specific instruments until they have actually, met with me and had a brief training session.
Yeah, it's a great system, and definitely not every group does it. So
for research groups, that's less relevant because since I have user facility research groups, maybe they bring on a new undergrad or a new grad student once or twice a year.
Yep.
Then the advisor is always just going to say, hey, shadow this person, whatever, and nobody's going to be using equipment that they haven't been explained to. But for the user facilities, I'm training usually a couple people a week or something like that. And so then I need a way to just make sure that they've been briefed and they have somebody they can talk to. And I'm in the process of writing SOPs for all those instruments. Yeah. I have maybe 8 or 10 done for the most utilized ones. Some of them nobody ever asked to use. So it's harder for me to build up the energy to bother writing an SOP for something that I've never even had to do a training on and nobody has access to.
Sure.
But we'll get through all of them probably by the end of next summer. So
another thing that's really apparent in material science engineering is, it's not just me or you, or Dustin or Cody or any one individual or group of individuals that truly care. There's true support of the top management from the department head that it's important, and anything less than the high bar that we set for safety won't be tolerated. Keen talked about top
I
management
think that's
support.
super important because I hear a lot of times from EHS and other groups, you hear, okay, we need to get a grassroots movement towards safety going, where it's like, we need to get the students to care and it'll work its way up. But that's not how it works, in my opinion. That's not how you try to establish a safety culture. If the advisors don't care, the students won't care. Even if they feel unsafe, they'll feel scared to speak up oftentimes, or they'll just find ways to kind of be safe on their own, but they won't, it's not the right way to do it because there's that hierarchy of sort of power in the lab space, and people are going to adapt to the culture that they're put in. Yeah. So you need the safety culture to be top down, not grassroots, coming from the bottom up. And so our department heads have always been incredibly supportive of safety. They have very limited tolerance for problems with safety. And so when we have issues with faculty not abiding by things, which we absolutely do, the department heads come down on them. And so we feel generally empowered that we can revoke swipe access for faculty and things like that if they're not keeping up with things, which we have done and will continue to do. And if they get mad about it, the department head does not side with them. And so there's
a lot of people jealous right now.
Yeah, and it took a while to get there. And there were definitely times when, we weren't able to rein in faculty. I think a lot of it has just come because a lot of older faculty that may have had less interest or whatnot have retired, and younger faculty, especially, pre-tenure, they just get here, they're going to conform to what the standards that are being abided by are. And so, we have a lot of faculty, senior and younger, that care, but I feel like over the time it's just kind of shifted because you're able to get the more people on board earlier on. So, I'd say since we have probably a good, 90+% of our faculty very on board with safety, then ones that are less are not going to make waves about it. They don't feel empowered enough to speak up.
Exactly. They become the minority.
Which is, good because you have that, our new department head, Dr. Morrow, is incredibly safety conscious. His group has always been one of the best in the building. They recently got 5S certified as well, which is great. So he has a very limited tolerance for, any unsafe behavior.
And I have an exact example I was going to bring up. So I was on an email about doing an interview, kind of like this, in a lab, and I think someone mentioned, like, hey, for the sake of the video, is it okay if we not wear our safety glasses, just me in the room? And he immediately, instantly, safety glasses are required, no exceptions. You can wear them or find somewhere else. And I'm like,
yeah,
it doesn't get any better than that.
We're always willing to work, like when I have, there's certain rooms where if it's clear there's no evident hazards or things like that, and we've cleared it for like a high school demo or something.
Sure.
We'll make exceptions to the rules. We're not going to be rigid when it doesn't make sense to if we've cleared everything.
Right.
But I appreciate that, the faculty typically leave that call to us or EHS or things like that. We have one lab, microscopy lab, where we don't require safety glasses because it's optical microscopes and people want to look into them and there's no hazards in the room. So it's like, okay, that's, fine. Yeah. But, we have pretty strong, if we see people not wearing safety glasses in the lab, they get a warning. Second time, we CC their advisor on that warning. And the third time we just cut their access and they have to redo the safety training. So that's a pretty good, nobody really wants to do that. So, it, typically doesn't make it past 1 or 2 violations.
Yeah.
It's always fighting against that sort of stuff because, safety is something that slips very quickly if you aren't, on top of it. And so we try to keep, a pretty consistent presence on things.
I appreciate that sentiment. It doesn't happen automatically. That's what we always tell people. People say oh, safety is common sense. I was like, well, how come not everyone's safe? Why do accidents happen then, right?
It's not, even as far as Matsy has gone with safety, it's still, something that it's never just going to roll on its own.
Right.
You have to keep checking in and, ensuring that things are being, managed properly because otherwise things will always backslide a bit.
Yeah, I agree.
And so, that's one of the big challenges is just ensuring that we're keeping constant sort of vigilance on top of that sort of stuff. And, we're certainly getting better at it, having, more help with Dustin Spicer and Dustin Allman, who is also hired because, I often need a lot of help myself because the safety isn't the primary aspect of my job. And so it's, something that I have chairs of the LSM committee that help me a lot as well. They do safety outreach events, once a semester and one in the summer too, with the students where we provide some food and they play some safety related games. Sarah, I'm sure, talked about the safety Olympics, things like that. So we try to embed it into the culture as best we can. And, we mostly, we recognize there's always going to be some things that are questionable or, unsafe, but we want to develop one where, the first thing students do is to alert us or ask. I think we've seen a lot of that with EHS, where students are coming to you guys being like, hey, we're installing, we're going to use this chemical, we need to do this process. Can you come over and take a look?
Yeah.
And that's what we want them to feel comfortable doing, because, if you don't have that top-down support and you don't have the faculty on board with bringing EHS into the lab to work on that sort of stuff, then it can be a problem. And so I think that's one of the big things that we have that's an advantage, is that's one of the first things people think to do is like, hey, let's ask about this. Exactly. I get CC'd on tons of questions to you and things like that students ask, and I'm always really happy that they feel comfortable reaching out to you guys.
Yep. And we talked about this in the last one too, about your role and the rest of the team. It helps students understand that EHS is an advocate and a partner, not just an external entity.
Fight.
When we started together and I started at EHS, I was determined to make sure that the EHS presence didn't feel like, oh, we come and do inspections or audits and that's it. That's why I rebranded the whole idea of our routine visits as consultations. That's why each individual appointment was made directly to the PI and then their appointed lab safety manager. And back to the lab safety manager role, one thing that I would characterize as, you have a really good one is when I, come around and they just give you the full tour. They're like, at this station, this is what we do, and this is how we do it. And over here, this is our instrument. This is what this does. This is safety implications. That's the best version. Because others, you show up and they're like, oh, what are we doing? Like, what are we here for? So
some of that comes with the experience. First year LSMs are going to be less aware of exactly what they're supposed to do during that. But ones that have done it once or twice are like, yep, all right, here's the drill. Let's roll through, because some people will stay on as an LSM for multiple years, which is totally fine. I often encourage switching, because then you have more people in the lab, that have had that experience. And so it, generally increases. But we've had some very good ones that have served a very long time as well. So.
And to combine the two topics, we talked about your teaching LSM model. There's an LSM course, right? Run
Sometimes,
credit?
Yeah.
Okay.
So we used to run that where it would basically just be a 1-credit grad course. The purpose really was just try to give the LSMs something for their time. I haven't run it recently just because, it really just consisted of 4 guest lectures typically throughout the semester, which were fun, but I can just do those in the meetings anyway that students are going to show up to. And one of the things is, a lot of the grad students are post-comps, and so then even taking a course that's 1 credit can become problematic with regards to how much they're allowed to take. They could always audit it, but it just, I think from a resume standpoint, it wasn't that helpful. So we're more transitioning to working with you, to maybe once a year offer essentially as MATC 590 or, as that safety class, or 597, I think it was, because it's a special topic.
Right.
But as that, having the OSHA cert, the 10-hour OSHA cert instead, because the students are far more interested in that, because, they already have the LSM bit on their resume. Having the course credit didn't really do much, but getting an actual tangible certification out of it, they're much more interested in. So that's more of what I've been leaning towards, is just offering once a year, basically, where it's like, hey, you attend these 4 or 6, however many you decide to do, breakdowns, and you'll get your 10-hour OSHA certification at the end of this. And students,
I'm happy to do it. I love doing it.
Yeah, I'll be in touch with you about doing it. I'd like to have that in the spring. So
no doubt. Yeah, I see that as like a mini version of my class, and then help spread the word, and it's helped that class grow as a whole. So
it's something the grad students like, because it really does give them something that they consider.
They get the credit, but a lot of them, like you said, don't even need it. So then to give them that tangible thing that they put on their resume, or keep in their wallet, even physically, and it helps them be more marketable, to have that foundational understanding of safety in the industry.
So that's really kind of how I've been moving it recently.
And then we have the LSM. Well, not LSM, because it's required for all grad students, a series of seminars. And one of those seminars, I believe, is always dedicated to safety. Is that kind of right? Yeah.
So MATC 590 is really just the seminar course. Most grad schools have these for their programs where, there's visiting speakers that come in and talk about, their research or things like that. It's meant to expose, grad students. It's networking. It's learning about other research. It's, bringing other important faculty here. It helps develop ties. But one of those every year we always have. I think it's always the second one. The first one's usually just like orientation, basically, in a sense, to the department for newer students. But the second one is always safety oriented. So a lot of times they get you to do that one. And so, that's important, because we want to start off strong on that.
Did you hear about this one this semester? It was fun.
I had not.
Yeah,
I always have class during it. I usually teach, so I'm not usually able to come by.
I'll tell you about it if you don't mind. So the theme was incident investigation, and I called it incident investigation, a piece of cake, because we did an exercise where they do a causal diagram and have to kind of investigate a near miss. And the top performers won cake.
No, that's
So they get to realize that, oh, it is in fact a piece of cake. So I had a whole like theme of cake and everything. And yeah, it went really well. Dr. Mara was really complimentary about it, and it was a fun time. So we'll jump to the Industry Advisory Board. I mentioned that a bit earlier. This is, I think, a game changer aside from, you guys and the personnel that support safety, the top management support of it, the overall culture. One of the main drivers I would point to, but I'm interested in your perspective, is the Industry Advisory Board, because I know they have a strong flavor of safety. They talk about, other things and workforce development and everything. So can you talk about that Industry Advisory Board, maybe what groups it's made up of, their kind of purpose, and you can talk about things other than safety, kind of what they drive. I'd be interested to hear, and then their role of safety.
So we have a sort of advisory board that comes to visit twice a year. So I think their visit is coming up. Should be probably around October 20 or so. I think they usually come for homecoming weekend. But, anyway, it's made up of alumni from MATC, basically, who are usually quite accomplished. So you're looking at, it's not just industry. It's also, some of them have been in academia or government or various places. Most of them do happen to be in industry. But, there have been previous, CEOs and, people very high up who've, done really well for themselves and sort of want to give back to the MATC program via advice often.
Sure.
And so they come by and we present to them over the course of a couple days. They meet with students often. They'll do little panels with the undergrads to answer questions. They'll have breakfast with grad students, things like that, to kind of get an idea of what's going on and also provide advice and networking opportunities for them. And then, we have a number of presentations, one of which is on safety. Some of them are on things like accreditation for ABET or the state of the undergrad program, the state of the grad program, number of students, challenges we're facing, new classes, all sorts of stuff, just sort of the general health of the program. And so then they give their feedback and try to help where they can. And this is an important part of the ABET accreditation for engineering programs, is to have something like this. So it's very helpful for us often because they do have good advice. And a lot of the turnaround in MATC safety that I think started around when I was a grad student, I believe, and I can't say this for certain because I know there was a strong push from, department head as well and things like that. But I believe a good portion of that came from the EAB, the advisory board.
Right.
Because they came in, they see stuff they don't like safety-wise, and so they, make a significant issue of it and drive a lot of these changes saying, hey, we want your students to be coming into industry with an industry understanding of safety and industry standards. So probably some of it could have been coming from students that they're bringing in from universities that are just very poorly equipped to handle safety properly. And so I think they were a bit of the spark that sort of got MATC going as far as rising up in terms of safety standards and things like that. So we do owe them a lot for that. There have been, Ryan Dirks in particular was a very big driver, a really big safety guy out of Arkema.
I would definitely agree. I think they were a major catalyst of it. I know they'll do walkthroughs, and
every time they visit, they'll do a walkthrough of both MSc and Stidle, typically, which I usually try to attend if I don't have class at that time, which I shouldn't this year. So I should be good to go on both of those. So they'll walk through a lab, and they'll write down basically everything they think is unsafe or they have questions about, and that will go up to the department head. And department, we obviously want to look good, so we'll quickly get those sorts of issues investigated or resolved or things like that. And, Sarah and I both sort of do what we call, mine's a little different because I don't have as many discrete lab spaces to go through, but we'll often do kind of a good lab, bad lab, where it's like, here's a lab we think's doing a really good job, and here's a lab we have a lot of problems with. And so, then that puts a little pressure, hopefully, on the bad lab to improve because they're going to be inviting a lot of scrutiny from, fairly powerful figures. And it gives the good lab a chance to shine and, see what we would like to apply to try to disseminate a bit more. So it is helpful just because it often, if you have faculty or students aren't listening as much to, the department or myself, to sort of bring that extra weight on them a bit can really help to improve things. So.
Yeah, I wouldn't undercut the importance of recognizing the good, but it's funny because I can remember, I think they pointed out something that's like, man, I don't think anyone would have really caught that. And they even express it as if this existed in our labs, it would be shut down right now. And there would not be able to work. And I'm like, man, that no wonder they have the influence that they do, right? Because students are like, oh, okay, this is what it's like in industry for that workforce.
And they have that expertise as well, which is really good because, they have worked in these areas. And so depending on the research, they know a lot of that. And some stuff, we look into and it's not a problem. Like I remember one of the things they came through, we have a lot of liquid nitrogen cylinders in the lab and, dewars and all that sort of stuff. And they were basically, question about ventilation, is there any sort of suffocation risk? And so, we did some calculations, looked at OPP, and it's like, no, even if every single one of these ruptured at the same time, there'd be no trouble breathing.
Well, it's a big space, but we kind of...
we're looking at ventilation rates. Calculations were done to make sure that, that wasn't actually a problem. So, some things, we check into and we determine it's okay. And some things we are check into and are like, okay, this actually could be something we need to address this.
Exactly, yeah. No, it's an invaluable, I think, asset and, program that you have there in relationship with the advisory board.
Speaking of which, I guess I always do like presenting them the previous EHS inspection. If you can get me that data before.
I owe you that. Yeah.
If you can get me that data before, in the next week or two, that'll be very handy.
Yeah.
So I like to be able to show, here's, some of our most common areas of weakness. Here's the number of, violations that we call, here's the comparison to last year, previous year, et cetera. So
I think you'll be happy with it. I didn't get to dive in it too far yet. There's a reason right now the system is showing me duplicates of everything. And so it'd be really annoying and tedious to manage that in Excel. So I'm waiting until it gets cleaned up. I owe you that for sure. That is something that, I do for each department, and this might, be beneficial for listeners, is I'll characterize by like finding category or EHS program, like the number of findings, and then we'll look a bit closer on which specific topics or, questions from a checklist, really what it is, has the most findings. And that gives us a way to use leading indicators to like, okay, this is our target area. We've been the highest in maybe the past couple of years here. We want to reduce that. And that allows for maybe more targeted like self-inspection of like, okay, let's focus on this. That's what we use it for,
because I see like, okay, like last year, the previous one, chemical waste and storage were the biggest areas. We're looking at probably 20-30% of the violations. So it's like, okay, well, we're going to make this a focus at LSM meetings. We're going to put it on the stall walls. We're going to make safety moments about it. We're going to try to drive those down. So it's useful data for us to figure out, where our weak points are. Some, where it's like, okay, well, they flagged this a bunch of times, so we don't think that's a viable issue. Let's go talk to EHS and work out like, this is not something that we can or are willing to change because we don't believe it's a hazard.
Yeah.
So
another kind of interaction that comes to mind is after we got to know each other and everything and had some routine consultations to get a bit deeper, I worked with LSMs and they were gracious enough to kind of invite me in and actually like shadow job operations, because that is to me like that next level of, you can only do much safety by inspecting physical conditions and walking around. At some point, of course, you have to be around people actually physically doing work. And so I got to, pour some glass in Dr. Morrow's group, a few others. I won't go through specific examples, but those are the kind of interactions in the lab that really make the difference, I think.
Yeah.
So looking forward to more of those.
It's very helpful. Yeah. I always encourage students to invite you in, especially when they have a new process.
We did HF etching. That was another one that came to mind.
That's a good one to do. Yeah. It's especially we try to bring you in for some of the more risky processes so we can identify any potential issues that we're not seeing. Things like that. Get another set of eyes.
Well, anything else?
No, I think that's about
I had fun. I hope you liked the experience and everything.
It's kind of cool. I never got to do something like this before, so I had a good time.
Yeah. I think we could have follow-ons.
You're welcome to invite me back whenever if you want a specific topic or something like that. And, an interview, I can always, if you want to do one with, the LSM chairs or something, I can.
That's exactly what I was thinking of, actually. I think that would be really helpful because other groups, universities, whatever, can use that as like motivation or whatever to their LSMs or their version of that.
I know it's growing around here. I'd had meetings within the last year with both nuclear and chemical engineering. They basically emailed me and was like, hey, we'd like to know more about, your LSM program, what you do. And so then we chatted, and I think they're trying to boot up similar things in their departments. So.
And folks in Shima will know we have an emphasis in, I think it's February, of what we call Lab Safety Week. So part of my contribution to Lab Safety Week, I'm thinking, is doing that panel interview of like LSM. So that would be awesome.
Help put that together for you. Shouldn't be a problem.
Awesome. Thanks, man. It was fun.
Yeah. Thanks. Appreciate it.
All right.
Mm-hmm.